Let's talk about how to use ACF and PACF charts to identify the analysis model for seasonal data. In practice, you can frequently see seasonal time series analysis. For example, a company can sell more ceiling fans in summer, so the sales revenue will go up in summer. But the company will sell fewer ceiling fans in winter. Then the sales revenues will go down in winter. And then next summer, the sales revenue will go back up. Next winter, the sales revenue will go back down. You can see the repeated ups and downs. The repeated ups and downs form a seasonality in a time series data set. A seasonal data set consists of two parts, a non-seasonal model and a seasonal model. The non-seasonal model looks at the long-term trend, and the seasonal model looks at the changes among seasonal cycles. In practice, we usually use ARIMA, lowercase p, d, q, and then uppercase p, d, q, and s to represent a time series data with seasonality. Lowercase p, d, and q are the parameters for the non-seasonal model. Uppercase p, d, q, and s represent the parameters for the seasonal model. I have recorded a video showing everyone how to use ACF and PACF charts to identify the values of P, D, Q for the non-seasonal model. I listed the video link down below. Before you proceed in this lecture, make sure you study that video first. That will help you to understand this lecture much easier and better. If you have studied that lecture, let's use the knowledge we learned to identify the values for P, D, Q, and S. This is our job in this lecture. Let's talk about the easier part. Let's talk about the values for lowercase d and uppercase d. Obviously, they represent the number of different things we need to do. When you get a data set, the first step is to draw a plot chart on top of the original data set. You want to observe if there is an obvious, consistent increasing or decreasing trend in the plot chart. If you do have an increasing or decreasing trend, then we should consider using one-leg differencing to difference the data set. We need to give value 1 to lowercase d if we have a long-term decreasing or increasing trend. If you find that your data set, your time series data set, is pretty flat, there's no obvious trend in the plot chart, then you don't have to do differencing on the non-seasonal model. Basically, you give 0 to the lowercase d. The uppercase d represents the number of differencing you want to apply among the seasonal cycles. If you find that some seasonal cycles are wider and taller than others, you want to apply one-leg differencing among the seasonal cycles to transform those cycles into stationary data. You want to give value 1 to the uppercase d. Because we do one-leg differencing among cycles, if you give 1 to the uppercase d, basically you want to subtract the previous cycle from the current cycle. If you find that the cycles are basically in the same shapes, they are in about the same width and heights, then you don't have to do differencing among the seasonal cycles. You can give a 0 to uppercase d. S represents the number of time spots in one seasonal cycle. If you find that every 12 months you have a pattern, an up and down pattern, then the value for S in that case will be 12. If you find every 4 months you have a repeated pattern, then in that case, the value for S should be 4. Now let's talk about how to identify the values for P and Q. That's a bit challenging. Drum roll, please. Okay, if you get the ACF and PACF charts, we follow what we learned in the previous lecture. Make sure you study the lecture down below. Let's identify the values for lowercase p and q. In this example, we find that there are a few significant spikes at the beginning of a PACF chart, but there is only one significant spike at the beginning of an ACF chart. According to what we learned in the previous lecture, for the non-seasonal analysis, we should use MA1 model. So the p-value, the lowercase p value should be 0, and the lowercase q value should be 1. Now let's identify the values for uppercase P and Q. They represent the seasonal analysis model, right? Here is a rule. We want to use the chart with a fewer number of repeated significant spikes to determine the seasonal model. In this case, which chart has a fewer number of repeated significant spikes? ACF chart. In PACF, we have a lot of repeated significant spikes. They are happening at leg 12, leg 24, leg 36, and so on. So we will not use it. But in ACF, except for the very first significant spike, we only have one more significant spikes. They are happening at around leg 12. You can find that, right? So we decide to use the ACF chart to determine the seasonal analysis model. ACF determines MA model or AR model. MA model, as we learned in the previous lecture, right? If you haven't studied that, make sure you study that. ACF determines the MA model. Except for the very first significant spike, how many times the significant spikes appear again in the ACF chart? Just one more time. The spikes are at the significant spikes are at leg 11 and leg 12. For this case, we have decided to use MA model for the seasonal parts, and the order for that MA model should be 1, because the significant spike only repeats once in the ACF chart after the initial significant spike. Then we can make a conclusion. The value for uppercase P is 0. The value for uppercase Q is 1. What if I have another set of significant spike show up again in the ACF chart? Let's say I have a significant spike show up again at leg 24 here. Except for the beginning significant spikes, how many times the significant spikes show up in the ACF chart now? Twice, right? They are at leg 12 and leg 24. In this case, for the seasonal model, we should use MA2. Then the value for the uppercase P should be 0. The value for uppercase Q should be 2. Some classmates may have a question. Why we ignore the beginning significant spikes? The reason is we used the beginning significant spikes to determine the non-seasonal models. That's why for the seasonal analysis model, we will not consider the beginning significant spikes. Let's see another example. I want to give you some time to think about this question by yourself. Just a little exercise. And then I will talk about how we identify the values for lowercase pq, uppercase PQ. Think about it. Let's talk about the answer. We need to look at the beginning significant spike patterns in ACF and PACF to identify lowercase pq value, to identify the non-seasonal model, right? According to the ACF chart, we find a few significant spikes at the beginning of ACF, but they are quickly decreasing to the zero line in the middle. At the same time, in PACF chart, we only have one significant spike at the beginning of PACF chart. So for the non-seasonal model, we should use which model? AR1 model. That's why the lowercase p value should be 1. The lowercase q value should be 0 in this case. Then we need to identify the seasonal model. Do you still remember the rule I introduced to you just now? We need to choose the chart with a fewer number of repeated significant spikes. Which one has a fewer number? ACF chart. In the ACF chart, except for the beginning significant spikes, how many times the significant spikes show up in the ACF chart? Twice. They are happening around leg 12 and leg 24. So for the seasonal analysis, I would choose MA2, which means the value for uppercase P is 0, the value for uppercase Q is 2. But some classmates may have a question. Why in the final result, for the seasonal part, you choose MA1? The reason is the significant spikes happening at leg 24 in the ACF chart just marginally passed the threshold, the blue dashed line. So for the model simplicity purpose, I would choose MA1 for the seasonal part in priority. But for the standard answer, you can choose MA2 for the seasonal part. This is how you identify the seasonal model according to ACF and PACF charts.